So now that you've done the lab and we've talked a little bit about this idea of centripetal acceleration, I want to connect your lab results to the equation on your formula sheet. So the people who did a force versus velocity graph tended to get these parabolas, which tells us that force is related to velocity squared. Now, we had some people who, instead of experimenting with the velocity, experimented with the acceleration. Experimented with the radius. And they got these inverse graphs, which tells us that force is related to 1 over r. Now, I didn't have anyone experiment with the mass, but I did have different people use different masses. And we saw that when the radius and the velocity were the same, a bigger mass required a bigger force, which tells us that that force is related to the mass. Now, if I combine all three of these together, and I'm going to go ahead and add a little subscript c to indicate that I'm talking specifically about the centripetal force. It's going to be mass times velocity squared all over radius. So that's the equation that comes out of the lab you did. Next thing I want to do is combine that with our formula sheet. So I've got a screenshot right here of the formula sheet that you've been using all year. And there's two things I want to pay attention to. So first up, this doesn't have centripetal force on here, but it does have Newton's second law, which we figured out earlier this year. A equals net force over mass. The other thing I want to pay attention to is we've got centripetal acceleration on here. So we have AC, centripetal acceleration, is equal to v squared over r. So what I'm going to do on the next slide is do some combining these two equations. So for an object that's undergoing, or first thing I'm going to do, I'm just going to rearrange the second law, and I'm going to say force equals mass times acceleration. Now, for an object that's experiencing a central net force and is going in a circle with a pretty constant speed, the net force in this case is the same as the centripetal force. So that means my acceleration is going to be the centripetal acceleration. So my acceleration equals v squared over r. So now I'm going to go back to Newton's second law, and instead of acceleration, I'm going to put v squared over r, which that right there is consistent with the results we got in the lab. We have that direct relationship with mass, we have a quadratic relationship with velocity, and an inverse relationship with radius. So now, thinking about problems, we're going to approach these really similar to how we approached Newton's second law problems. So your first step is going to be to do a free body diagram and do a vector addition diagram that you will use to find that net force. Then, once you know your net force, or what forces are responsible for that net force, you're going to combine that second law. So F net equals ma, And you're going to combine that with our centripetal acceleration equation. And then you'll be able to work through with the variables you're given to solve for the information you need. So you should be set to do some problems.